The universe, the miracles it beholds, the beauty of it all, and the balance, keeping everything in perfect harmony, has always been a source of wonder for the human mind. In the early days of humanity, our ancestors would look up in the sky and simply wonder about all that there is in the heavens above. And for humankind, so began a tryst with the stars. In the millennia that have passed since, humans have tried to explain what they saw in the night sky using stories, theories, and explanations, greatly influencing the ideas of philosophers and scientists over the ages, and bringing the whole of humanity to what we understand of the universe in the present days. And yet, this is but a drop in the ocean. We just have begun to understand what was, what is, and what could be or will be. Of course, the wonder itself began billions of years ago, when from nothingness was born all that we see in the universe in a majestic blaze, and the chaos that followed soon after that, in the age of expansion, gave way to order and the formation of the first stars and galaxies in an infinitely complex universe. Over the ages, our own galaxy evolved from the merging of early galaxies and interstellar gases, and our sun and planet were formed from the remnants of these early stars. Thus, the very genesis of humanity can be owed to the stars, deepening our connection to the cosmos and our yearning to better understand the universe. We know where we belong to, where we are from, what are we made of. But to understand where we are going, that is the real question. For everything that has a beginning must also have an end, and so arises the question, will the universe ever end? Upon observing a perfectly balanced cosmos, it is natural to desire its eternal survival. However, in the same manner that stars and planets come to an end, it is possible that the universe too will. Perhaps it may continue to expand until comes a day that all of this might collapse into nothingness. The same way that the universe came into being, leading into the next stage of the cosmic calendar, maybe even a new universe. Or maybe the laws of Newton may apply, in a philosophical sense, that the universe will continue to be in a state of expansion and existence through eternity. But whatever the outcome is, we know that until then, we have an entire ocean of knowledge to explore. With a universe so vastly unexplored, it is tiring to get tired. And so, join us as we explore the cosmos from the comforts of our homes. That will take our minds to the far reaches of space, to the many wonders that our universe has to offer, and to explore the ancient wisdom immortalized by the cosmos.
Hello and welcome to Celestia's Guide to the Universe. I'm Pratik Upadhyay
And I am Abhisharan.
and we will be your hosts this evening. In today's session, we will take you through the cosmic miracles in the sky above us. We will explore many interesting celestial objects while stringing together a story of how all existence came to be. For those of you who are wondering what this is a space engine, a realistic virtual simulation of the universe around us. This virtual universe spreads across billions of light years and contains trillions upon trillions of planetary systems. However, keep in mind, ladies and gentlemen, that everything you see in this simulation is based on actual scientific observations or is constructed using data that we've obtained. As we begin our voyage through the universe, everything that you observe is shown exactly as it is thought to be by modern science.
Okay, so if we were going to start somewhere, let's start from the beginning. So let's rewind our clocks to what scientists believe is the earliest event in the history of our universe, the origin of universe, the Big Bang. So what exactly was the Big Bang? Okay, imagine everything in this universe condensed into one tiny point of matter and energy. This minuscule, tiny, itty bitty point, the dense object, not only contains the energy and atoms of everything that has ever existed or will ever exist, but it also contains both space and time themselves. This extremely dense point exploded with unimaginable force, creating matter and propelling it outward to make the billions of galaxies of our vast universe. On your screen, those tiny dots which we are traveling through are not the stars, these are those trillion galaxies itself.
The universe is in fact so old that the first stars didn't appear until 100 million years after the Big Bang, and nearly a billion years passed before galaxies proliferated across the cosmos. These ancient stars produced and dispersed the first heavy elements, paving the way for the eventual formation of the solar systems like our own. In the words of Carl Sagan himself, we are made of star stuff. The statement throws light on the fact that every fundamental building block, like carbon, nitrogen, and oxygen atoms that constitute our body, were in fact formed inside previous generation stars. So, what better way is there to unravel this universe than to follow the life cycle of a star? So strap on your seatbelts and get ready to journey through the cosmos to the place where it all began.
Stars, the most widely recognized astronomical objects, represent the most fundamental building blocks of galaxies. But wait, how exactly is a star born? Is there a place where it all happens? The answer is a perfect yes. The birthplace of a star is a nebula. A nebula, an enormous cloud of dust and gas occupying the space between stars and acts as the genesis chamber or the nursery for the new stars. The turbulence deep within these clouds is what gives rise to the knots with sufficient mass that the gas and dust can begin to collapse, and that too under its own gravitational attraction. As the cloud collapses, the material at the center begins to heat up. This is known as a protostar, the hot core at the heart of the collapsing cloud. This protostar will one day become a star as we know.
One needs to understand that a protostar isn't stable in nature. It isn't a separate state. It still has large amounts of matter falling inwards, adding to its mass and helping it grow. And this process isn't quick either. For example, if you were to look at our sun or stars that resemble our sun, the protostar phase would have lasted approximately 50 million years. Okay, and once the core temperatures reach somewhere around 10 million Kelvin, the optimum temperature for efficient hydrogen fusion is attained. It is at this point that the conversion of a protostar into a main sequence star is completed. Throughout the cosmos, you'll find nebulas which are fundamentally similar, right? At the end of the day, they're just suspensions of dust, gas, and other interstellar materials. However, they happen to be a pretty diverse lot. They vary in terms of composition. Some of them might just contain enough matter to give rise to a single star, while there are others whose masses are far, far greater than the mass of our own sun, about 100,000 times as much. These nebulas are called diffuse nebulas, and they give birth not to one star, not two, but give birth to star clusters. The nebula you guys see on the screen is called the Orion Nebula, which happens to be a diffuse nebula. And the reason why it's shining so brightly is because it happens to house a cluster of stars called the star trapezium at its center. In fact, it happens to be so bright that if you happen to observe the Orion Nebula, you can actually locate the Orion Nebula within the constellation.
All right. So our next stop of this voyage is the Red Rectangle Nebula. Let's just travel to it. This nebula is a part of the constellation Serpens, and you must be wondering uh, why is it called a rectangular nebula? So when it was first viewed through a telescope, it looked like a perfect rectangle and hence got its name. With further studies, we found out that it actually is a bipolar reflection nebula and thus one of the most symmetrical celestial objects of this cosmos. It was first imaged in 2007, and about its formation, no, please don't ask that. It's still a mystery.
Now, moving on to the third nebula called Cat's Eye Nebula. Cat's Eye Nebula is part of the constellation Draco and was discovered by Herschel 1786. This magnificent, beautiful object goes by several names: Sunflower Nebula, Snail Nebula, and several more. The Cat's Eye Nebula is classified as a planetary nebula. However, keep in mind that this has nothing to do with planets at all. A planetary nebula is what happens to a star when it reaches the end of its life. Okay, so a star such as our sun, when it would use up its hydrogen, its fuel that sustains itself, it would end up shedding its outer layers, forming a planetary nebula.
So, last but not the least, we have the diffuse nebula. Let's just travel some light years to it in the few milliseconds. All right, this beautiful nebula is what exactly is called a diffuse nebula. The diffuse nebula are clouds of material formed from the explosions of few stars and leftover hydrogen and helium from the Big Bang. Most nebulae can be described as diffuse nebulae, which means they are extended and contain no well defined boundaries. These nebulae are actually the birthplace or nursery of the stars. Now, those tiny dots you see in the center of this nebula are actually a star cluster in the making. Also, I would like to tell that all these different colors you see are due to the different elements or the different gases present in these celestial bodies.
This might make you wonder about the genesis of our solar system. How did our beloved sun come into existence? After all, billions of years ago, it was just an accumulation of dust and gas suspended in space like any other nebula, and it was called the solar nebula. The solar nebula also went through similar steps while forming our sun. As the mass of the proto-sun increased, so did its gravity, pulling the surrounding matter towards it. And as they fell towards the center, he started to rotate about its axis and formed a disk of matter around the center. This is actually based on a very simple principle of conservation of angular momentum, which most of us should have come across by now. So, such a simple law gave birth to such a huge and complicated system. And believe it or not, the sun ended up consuming 99.8% of the total mass of the solar nebula. So, despite having 8 planets, countless objects within this system, they collectively only account to 0.2% of the total mass of the initial nebula. And as the matter in the disk surrounding the proto-sun began to cool, clumps of matter started to form, which eventually developed into planets, moons, asteroids, and comets. So, in a way, we can say that all the planets in our solar system were made from the leftover material of the sun's birth. And this is also the reason that all the planets in our solar system are found in the same plane. On your screen, the light green orbits basically highlight the orbits of our planets. And if you observe carefully, they all lie in the same plane with the sun at the center.
However, only one of these planets had the perfect conditions for life. And as we all know, it's our home sweet home, the Earth, the third planet of the solar system. The rotation of this Earth causes night after day and shows us the incredible night show. The different constellations moving from east to west, each with its own wonderful stories from different legends of various civilizations. And not to forget the beautiful deep space objects that lie in. Since time immemorial, humans have been fascinated by the wonders up in the sky. People started mapping the sky, scaled the time, prepared calendars, and whatnot, and everything based on these celestial bodies and their appearances. The stars and constellations remained the only source of navigation and direction for a long, long time. The Greek, Babylonian, Egyptian, Indian, Chinese, etc., all over the globe contributed to it in their own ways and gave different hypotheses. There always has been this way of passing information as a stories from one generation to the next and next. So these different ancient groups of astronomers came up with their stories, which we today know as legends or mythologies. Mapping the sky and recognizing these collections was actually made easier by portraying it to some character and driving behind a legend with it.
Up until this point, we have spoken a lot about the formation of stars and about how these celestial bodies came into existence. We now move on to the next phase in its life cycle. You see, these constellations aren't just made up of stars. They are also made up of nebulae, star systems, and a variety of other deep space objects. A star system fundamentally basically comprises of a small number of stars that orbit each other bound by gravitational attraction. These can be of various types. Like a binary star system consists of 2 stars, a ternary star system contains 3 stars, and a quaternary star system contains 4 stars, and so on. When the system ends up containing about hundreds or thousands of stars, it is called a star cluster. Similar to what you guys saw in the diffuse nebula which was shown after the Cat Eye Nebula. There happen to be 88 constellations that have been mapped in the night sky. However, we'll be looking into a few interesting ones today. So, ladies and gentlemen, moving on to the first constellation of today, Ursa Major. Ursa Major happens to be the most easily recognizable constellation, pointing to our pole star in the northern sky. According to Greek legend, Ursa Major was once a beautiful maiden called Callisto, whom the Greek god Zeus had an affair with. In order to protect her and the sons Arcus from his jealous wife Hera, Zeus turned them into bears. He then picked up the bears by their short, stubby tails and threw them into the sky. While doing so, the tails of the bears stretched out. As Arcus was turning into the small bear and came to be known as the Little Dipper or Ursa Minor, and was being placed in the sky by the god of gods, he turned and looked at his mother Callisto, who is now the Big Dipper or Ursa Major. That is why you can see that the Little Dipper is curved toward the Big Dipper so that Arcus can watch over his mother Callisto for all eternity. The Indians had their own theory. In Indian mythology, the seven central stars of Ursa Major that form the cup shape are referred to as the Sapta Rishis, meaning the seven sages. These are Vashishta, Bharadvaja, Jamadagni, Gautama, Atri, Vishwamitra, and Agastya. These seven rishis are often considered as typical representatives of the character and spirit of the prehistoric or mythical period. Another interesting fact is that Ursa Major is visible throughout the year for the observers that is situated in the northern hemisphere and can easily be spotted.
So now let's dive into the few deep sky objects of this constellation. First up, we have Alcor. It's a very faint star located at the tail end of our Big Bear. Let's just travel to it. All right. So Alcor is actually a binary star system, a star system consisting of two stars orbiting around their common very center. And these systems, especially when more distant, often appear as a single point of light to an unaided eye and then revealed as multiple ones by other means. So on your screens, you can see the two stars, one shown here with blue orbit and the other one shown as with red orbit. Now, moving on to our next destination, it's located relatively closer to this Alcor star system, that is Mizar. Now, this star system has a really interesting story behind. It was initially believed to be a single star system when seen, long time back from Earth. And it was not until 1889 that it was reclassified as a binary star. And further studies led it to be recognized as a quadruple star system, in which the very center of two binary sets are locked into a system with each other into another binary one. Okay, very similar to a binary one. And
Moving on.
if we connect these two systems to Indian mythology, we have Mizar as Rishi Vashisht and Alcor as his wife, Lady Arundhati. Next from this constellation, we have the pole star or Polaris. This star guided the travelers in ancient times and remained one of the most reliable sources to get the north direction. The Indian legend of this Dhruv Tara is the same good old bedtime story we heard from our grannies back when we were kids, the good old times. The story of a child named Dhruva who was an absolute devotee of Lord Vishnu and was blessed with the boon of knowledge. Now, on your screens, you have this Polaris or Alpha Ursae Minoris, the North Star, present at the tail end of constellation Ursa Minor. This is actually a triple star system composed of the primary star Polaris AA, which is a yellow supergiant in orbit with its smaller companion, and this pair is ultimately in orbit with Polaris B. This system was discovered in August 1779 by William Herschel.
Moving on to our next constellation, Canis Majoris or the Greater Dog. Canis Majoris, on the contrary, is located in the southern hemisphere. According to Greek mythology, Elaps was a dog that always caught whatever it hunted. The dog features in a variety of myths, including the one in which it was sent to hunt the Timesian fox, a fox that could never be caught. Realizing that they were doomed to be the hunter and hunted for all eternity, Zeus turned them both to stone and then placed them in the sky as constellations that we know as Canis Major and Canis Minor. The irony, of course, is that they continue to chase in an eternal hunt, with Canis Minor the fox rising in the winter skies about an hour before Canis Major, which is the dog, elapses. Canis Major is described as a dog with a blazing face, owing to the fact that it holds the brightest star in the night sky, Sirius. The reason why Sirius is so bright is because of its proximity to our planet. It is just 8.6 light years away from Earth. And also the reason why it's called the dog star because it happens to be inside the constellation Canis Major called the Greater Dog. However, despite being called a star, Sirius is actually a binary star system consisting of a main sequence star, Sirius A, and a faint white dwarf, Sirius B. We decided to choose this constellation for a reason, however, because it contains another object which is essential for our understanding. In order to understand further about the life of a star, we need to look into the giants. The main sequence stars, such as our sun, sustain themselves by using their energy by fusing hydrogen into helium. However, there comes a point in every star's life when it runs out of hydrogen. At this point, it starts burning helium. A blue giant is basically a middle aged star that has started swelling up. It is running out of hydrogen to burn, but hasn't started burning helium yet. The star you see on the screen is a blue giant called Mirzum. It burns while emanating a bright and beautiful blue light. The reason being, it burns hotter as it is consuming the last remnants of the hydrogen fuel. After a few million years, however, the hydrogen reserves are finally depleted, and as the star nears the ends of its life, it starts fusing helium nuclei to carbon nuclei. Helium being more heavy than hydrogen, and the burning of helium causes the star to expand even further, converting it into a red giant. What you observe on the screen is a red giant called VYCMA, and this is the final stage in the life of a star before it meets its end.
So when a star runs out of helium, it will die in variety of ways, like depending on its size. A smaller star to an average star will turn into a white dwarf or nebula. On the other hand, a larger star will experience a stellar explosion, turning itself into the brightest object in the night sky for a few moments. This brings us to the next phase of the life cycle of a star, its death. For stars like our Sun, this occurs as a powerful luminous stellar explosion called supernova. This transient astronomical event occurs during the last evolutionary stages of a massive star or when a white dwarf is triggered into a runaway nuclear fusion. This object ultimately collapses into a neutron star or a black. So on your screens right now, you have the Kepler supernova. This is really interesting since at one time it was visible to naked eye. Yes, you heard me right. Kepler's star was brighter at its peak than any other star in the night sky at that time. It was visible during the day for over 3 weeks straight. So, and records of its sighting actually exist in European, Chinese, Korean, and many other sources. Another pure interesting fact about this that it is the second supernova to be observed in a generation, and no further supernovae have been since observed with such certainty in the Milky Way.
Now, going to the ultimate stage in the life of a star, we have neutron stars and black holes. A neutron star is the collapsed core of a massive supergiant star. They have a radius of 10 kilometers and a mass of about 1.4 solar masses. Just to put this into perspective, the mass of the Earth is lesser than the mass of a sun to a considerable extent. And however, it has a radius of about 6,400 kilometers. The neutron star, on the contrary, just has a radius of 10 kilometers and is way heavier than the sun. So it happens to be infinitely more dense as compared to that of the density of the Earth. These things result from a supernova explosion of a massive star, and combined with the gravitational collapse that takes place, it compresses the core past the normal limit. A fun fact, neutron stars are super fast spinners, and they're capable of rotating about 716 times per second. This translates to more than 43,000 rotations per minute. Okay, so these happen to be peculiar objects in space, but not stranger than what we're going to talk about next. Our sun is a quiet star, and it'll eventually turn into a white dwarf when its nuclear fuel dies. However, this is not the case with many stars, like the ones which are 20 times more massive than our sun. When their fuel supply ends, their gravity overpowers them, and eventually the core collapses into a singularity, a point of infinite density, which brings us to the final frontier of our universe, a black hole. A black hole is a region of space time where gravity is so strong that nothing, no particle, no amount of matter, not even electromagnetic radiation such as light can escape from it. The black hole is so dense that it ends up distorting the fabric of space time itself, causing the light around it to bend and curve. The black hole you see is an ultra massive black hole. Okay, it is way bigger than the black hole that is found at the center of our Milky Way galaxy and happens to be one of the biggest. And coincidentally, it's situated at the center of a galaxy called IC 110, which is a supergiant elliptical galaxy and the largest known galaxies up until date. The IC 110 is populated by a number of metal rich stars, some of which are 7 billion years older than the Sun, which makes it appear golden yellow in color.
So, as well quoted by Stephen Hawking himself in A Brief History of Time, the universe does not allow perfection. So, last but not the least, we have some real treat kept for you all as the grand finale. Now we'll travel to a supergiant orbiting a small black hole. Yes, you heard me right. A supergiant orbiting a black hole. This tiny black hole, which you'll see in a moment. Yeah, this one, that tiny star-like looking. This black hole sort of feeds off the star in a sense that it absorbs absorbs the residual gases that the star emits. The star has a very tight orbit, which actually causes the elliptical or the egg-like shape of the supergiant instead of the normal sphere-shaped star. And all this is due to the immense gravitational pull of this small black hole. Believe it or not, this system actually exists in real life and was detected due to the massive pulsar beams it emits. Now, our next interesting object is the colliding galaxies, the Herculeus Galaxian Cluster. So, this is a pair of interacting galaxies consisting of two spiral galaxies, which are expected to, collide into each other in another billions of years. And this actually lies around 450 million light years away from Earth and is a part of the constellation Hercules, and hence got the name. Okay, can you imagine two spiral galaxies with black holes in the center colliding into each other in another billions years, and those radiations traveling to us in another billion years? And for an interesting fact, galaxies do collide. It is expected that our Milky Way will also one day collide into the Andromeda Galaxy.
So, before we end today's session, it so happens that Space Engine is capable of simulating the Halley's comet. Yeah, that's like the one comet everyone makes a fuss about. So, this entire process of simulating the Halley's comet happens to be a magnificent and beautiful one. So, this would be our last piece for today's event, and I urge everyone to observe it carefully. Halley's comet is a short period comet which is visible to the naked eye from the Earth every 75 to 76 years periodically. It is the only short period comet that is regularly visible to the naked eye from the Earth and is hence only seen by a human once in a lifetime or once or twice, depending on how long you live. It last appeared in the inner parts of the solar system in 1986 and will appear in mid-2061. An interesting fact about the Halley's comet is that as it approaches the sun, it starts to expel jets of sublimating gas from its surface, which knocks it off very slightly from its orbital path. You'll be able to see this in quite some time. Uh, the red line which you see on the screen is actually the path followed by the Halley's comet, and we're going through a time skip because it takes some time for the jets to develop. So, yeah, just bear with it for a moment. The Halley's periodic return was actually not observed and recorded by astronomers. Okay, Edmund Halley was the only person who identified it as a periodic event, and that's why it's named after him. Okay. So you can see the tails or the jets of gas, starting to form. So when the comet approaches the sun, the sublimating ice that include water, carbon monoxide, and carbon dioxide create a tail which spans across the orbits. Okay. The green lines are actually orbits of two planets. And you can see that the dust trail actually closes the distance. It crosses the distance between the orbits of two planets. And that's how huge that is. So this is what basically happens. And as it moves away, it'll eventually subside. The estimated period of rotation of the Halley's comet is 2 days, 4 hours between 40, and it's visible for about 43 to 48 minutes. So whenever it happens, I think the next one was mentioned to be in 2061. You would have about 45 minutes to observe this glorious event. And I guess that's it for the day. So thank you all for joining us, and I really hope you enjoyed this session. And please stay tuned in to our YouTube channel for more interesting stuff. Thank you.
Thank you, everyone.
हो गया ना खत्म हो तो क्या चल हाँ